Okay, so today we're going to be talking about parabolas, and this is all stuff that we have already been doing, but we're just looking at it in a little bit of a different way. So the equation on our left, that is our normal graph. When we think of parabolas, this is what we think about. They open up or they open down, making a U shape. So this is our normal graph, and we recognize that our x is being squared here, whereas our other equation, our y, is going to be being squared. So the first little bit is just a review. So vertex is h comma k. Axis of symmetry is x equals h. Or orientation, if our a is positive, then it's going to open up. If our a is negative, it's going to open down. And our a value is the number that's being multiplied by our x minus h squared. Our shape, now that also looks at our a value. If our absolute value of a is equal to 1, it's just going to be normal. If our absolute value of a is greater than 1, it's narrow. If our absolute value of a is in between 0 and 1, so if it's a fraction, that means our shape is going to be wide. Okay? And our x-intercept, where it crosses the x-axis, so our zeros, that is when our y is equal to 0, and our y-intercept is when our x is equal to 0. Now what's new about this is our P, Focus, and Directrix. So these three things help us to know a little bit more about our parabola. So our P is our distance from our vertex. We can find our p-value by our equation 1 over 4a. Okay? Our focus then is our distance, p, on the inside of our parabola. Okay? And this is going to be a point of our graph. And our directrix, that's going to be a line, and it's our distance, p, but it's on the outside of our parabola. Our directrix will never touch our parabola. Never ever. So, since our directrix is a line, we would draw it like we would our axis of symmetry, a dashed line, because it's not really on our parabola. And for our parabola, that is opening up or down. So if it will never touch it, that means it's going to have to be horizontal, so it's going to be in the form of y equals. Okay, and something to note is that that's going to be perpendicular to our axis of symmetry. Okay, so for our equation on our right, that is going to open sideways. And something to note about this is our y is being squared. So since our y is being squared, that's what changes this whole thing. Our y is being squared, so it's opening sideways. It's going to look something like this. Okay, or it could open to the left as well. And something else to note is that our h and our k have switched places. Now our k value is our y value of our vertex, so it makes sense that our k is going to be with our y. So, and then our h value is going to be on the outside this time. So, but our vertex is not going to change. It's still going to be h comma k. That doesn't change. It just changed. The thing that changes is the placing of the h and k. And our axis of symmetry, that is going to be our y equals k. It's going to be a horizontal line this time that cuts our graph in half. Our orientation, that's going to change a little bit. If our a value is positive, that means it's going to open in the positive direction, so right. If our a value is negative, it's going to open to the left. Our shape, we're going to use the same descriptors that we did for our normal graph. And our x-intercepts, those are the same. Y equals 0, and our y-intercept is going to be x equals 0, and these are going to be coordinates of those points. And now a p-value, that's the same. Our focus, that's the same. The thing that's different is our directrix. It's still the distance p that's on the outside, but instead of it being y equals like our normal graph, this line is going to be x equals. Okay? That's the one difference there. So if we're looking at our first example then, we have y equals 2x squared plus 8x plus 7. And what we need to do right off the bat is say, is this a normal graph or is this graph going to open sideways? Since our x is being squared, we know it's a normal graph because our x is being squared. And we need to get this in graphing form, or our vertex form. So to do that, we need to complete the square. So we're going to have y plus blank equals 2. We need to factor out this 2 of our x squared. And don't forget to factor it out of our b value. Plus blank equal, plus 7. And we would divide our b value by 2 and square it. So we're going to get 2 squared, which puts a 4 as our c value. And on the other side, we have this 2 on the outside. So we're actually adding a 2 times 4 to the other side. So that gives us our equation, and when we simplify this, of y plus 8 equals 2 times x plus 2 squared plus 7. And we need to subtract 8 from both sides to get y by itself. So that gives us our equation of y equals 2 times x plus 2 squared minus 1. And that is our graphing form. Okay, and since this is a normal graph, our vertex is just going to be hk. So -2, -1. Axis of symmetry is x equals -2. Our shape and orientation, we're going to look at our a value, which in this case our a value is 2. So our shape, since our a is greater than 1, it's going to be narrow. And our orientation, it's going to open up because our a value is positive. So now to find our x and y intercepts, it would be helpful to plug our equation here into our graphing calculator and find our zeros. When we do that, we will get a 1, 0 of negative, negative 1.29, comma 0, and a value of negative 2.71, comma 0. And we're going to get our y-intercept of 0, comma 7. Okay, so now let's graph everything that we know so far. So we have a vertex of -2, -1, and we have our x-intercepts of negative 1.29 and negative 2.71, and we have our y-intercept of 0, 7. Okay, so let's connect these points. Oops, I'm going to redo that. Here we go. So we have our points here. We've graphed them all. Now we need to find our p value. Now we need to know our a value before we can find our p, because remember our equation to find our p is 1 over 4a. So when we do that, we plug in our 2. So we get 1 over 4 times 2, which equals 1/8. Now this 1/8 tells us our distance from our vertex to our focus, which is on the inside of our parabola, and the distance from our vertex to our directrix. Okay, so if we start at our vertex, we're going up 1/8, so it'll be roughly at this point. So when we do that, we are going to have the same x value of -2, but then we're taking our y value of -1 and we're adding 1/8. When we do that, we get a y value of -0.875. Now for our directrix, remember that's a line, but we're going to go from our vertex and we're going to go down 1/8. Okay, and when we do that, we're going to subtract our 1/8 from -1. So when we do that, we get a value of -1.125. And since our directrix is, for our normal graph, it's going to be a horizontal line. So it's going to be y equals -1.125. And when we graph this, it's going to be a dashed line. Oops, and I forgot to graph our axis of symmetry, which is x equals 2. So just as a reminder, our vertex is -2, -1. That's this point. And our x-intercepts -2.71, 0. And this is -1.29, 0. And this is 0, 7. And then this line here, our directrix is, y equals -1.125. And then our focus is our point -2, -0.875. So that is that little point right there. That's our focus. Okay, so that's everything that we're going to be graphing for our parabola. So let's go on to this next example. Now looking at this, it's a little bit different. You should notice that our y is being squared, so this is going to open sideways. Okay, but in the same way, we have to make sure that we have it in standard form, and right now we currently do not, so we have to complete the square in order to do that. So we're going to have x plus blank equals, and since our a value is 1, we don't have to factor anything out. We're just going to have y squared plus 2y plus blank minus 3 is on the outside. Taking our b value, dividing it by 2 and squaring it, so we're going to have 1 squared. So that means we're adding a 1 there, and 1 to the other side. That leaves us with x plus 1 equaling, when we factor this, it factors 2y plus 1 squared. We got that 1 from our b value divided by 2. We have our minus 3. When we subtract 1 from both sides, we get this in factored form of x equals y plus 1 squared, subtract over a 1, -4. Okay, so at this point, our vertex, remember, this is our k and this is our h. So our vertex is going to be -4, -1. Be careful of that. Okay, our axis of symmetry, remember, that is going to be a horizontal line, so it's going to be y equals -1. Our shape, we're looking at our a value, it's 1, so it's just going to be normal. Our orientation, since our a value is positive, it's going to open to the right, where our a value is 1, because there's nothing being there, it's just imaginary 1. Now with your x and y intercept, it's a little bit different. You can't plug this equation into your calculator because it is not a function. So we're going to have to find our x and y intercept by hand. So our x-intercept, that is when our y is equal to 0. So when we plug 0 in, we would get 0 plus 0 minus 3. So x equals 3. That gives us our x-intercept of 3, 0. Y-intercept is when our x equals 0. And we have a couple ways to do it. We can either look at our original equation, set 0 equal to y squared plus 2y minus 3, and notice that we can factor that to y plus 3 and y minus 1. So we would get our values of y equals -3 and y equals 1. Or we can set this 0 equal to our graphing form and solve that way. But either way you do it is fine. So you would get your value of 0, -3 and 0, 1. So let's graph all these parts that we know, -4, -1. And we have our y-intercept of 3, 0. And we have 0, -3, 0, 1. Okay. Just realized I made a mistake, so this is a -3 here and a -3 there. Sorry about that. So when you have this, your graph should look something like this. Okay, and then your axis of symmetry, y equals -1. Okay, so then from here we have to find our p, 1 over 4a. That doesn't change. Our a value is 1, so we're just going to have 1/4 as our p value. So from our vertex, we're going to go in the positive value, 1/4. So we're going to add 1/4 to x. So we're going to get negative